From this configuration, current amplification factor gamma is equals to change in emitter current divided by change in base current. That is, change in output current is nothing but here emitter current, change in base current is nothing but input current. Then gamma is equals to, you will get IE by IB. Then IE is equals to gamma into IB. Okay, then gamma into IB is equals to IE, right? Already we know that IE is equals to IB plus IC. Then gamma into IB is equals to IB plus IC. Then gamma into IB, I can take this IB on LHS side, you will get gamma into IB minus IB, that is equals to IC, right? If I take IB as common, you will get gamma minus 1 is equals to IC. Then gamma minus 1 is equals to IC by IB. Already we know that IC by IB is nothing but beta. Okay, that is from common emitter configuration. Okay, gamma minus 1 is equals to beta. That means here we will get the relation between gamma and beta. Okay, next we will get a relationship between alpha, beta and gamma. Okay, see here in common base configuration, already we know that current amplification factor alpha is equals to IC by IE. In common emitter configuration, beta is equals to IC by IB. In common collector configuration, gamma is equals to IE by IE by IB. Okay, assume alpha equation as 1, beta equation as 2, gamma equation as 3. Okay, where alpha, beta, gamma are the current amplification factors. Okay, already we know that emitter current IE is equals to IB plus IC. Okay, from equation 1, IC is equals to alpha into IE. Substitute that value in above equation. You will get IE is equals to alpha into IE plus IB. Okay, then IB is equals to, from this equation, IB is equals to IE minus alpha into IE. Then you will get IB is equals to IE into 1 minus alpha. Okay, assume this is as equation number 4. Okay, divide the above equation by IC. Okay, then IB by IC is equals to IE by IC into 1 minus alpha. Okay, already we know that IB by IC, okay, IB by IC, that is nothing but 1 by beta. Beta is equals to IC by IB, right? Then IB by IC is nothing but 1 by beta. That is 1 by beta is equals to, now see here IE by IC is nothing but 1 by alpha. Then you will get 1 by beta is equals to 1 by alpha into 1 minus alpha, right? Then beta is equals to alpha by 1 minus alpha. You will get a relation between alpha and beta only here. Alpha is equals to beta by 1 plus beta. But already from the common collector configuration, gamma is equals to IE by IB, right? That is equals to IE by, already we know that IE equals to IB plus IC. Then IB can be written as IE minus IC, right? Substitute that value here, you will get gamma is equals to IE by IE minus IC. Okay, divide numerator and denominator by IE on RHS side. Why? Because if we divide and the numerator and denominator by IE, the resultant value cannot be changed, right? Then gamma is equals to IE by IE divided by IE by IE minus IC by IE, right? IE by IE and will be cancelled, you will get 1 by IE by IE again 1 minus, already we know that IC by IE is equals to alpha, that is gamma equals to 1 by 1 minus alpha, that is gamma is equals to 1 by 1 minus alpha, that is equals to 1 plus beta. If you simplify this equation, you will get 1 plus beta, that is will give the relation between alpha, beta and gamma, that is gamma is equals to 1 by 1 minus alpha, that is equals to 1 plus beta. Okay, that is about relationship between alpha, beta, gamma. Okay, all these three are the current amplification factors in case of common base configuration and common emitter configuration and common collector configuration. Okay, now we will discuss the input and output characteristics of common collector configuration. See here collector is common for both input and output. VBC is nothing but base collector voltage, that will be read by this voltmeter. Here IB is the base current, that is read by this ammeter. Similarly here emitter collector voltage will be read by this voltmeter. Okay, this ammeter will read emitter current. Now see here input characteristics are plotted between input voltage, that is base collector voltage versus base current by maintaining output voltage, that is emitter collector voltage, as keep constant. Okay, that means initially set VEC is equals to 0 by adjusting this VEE. Okay, by adjusting this VEE, initially set VEC to is equals to 0 and vary the base collector voltage in steps and note down the corresponding base current reading and plot the graph. Okay, same way repeat the above procedure for different values of this base emitter collector voltage and note down the corresponding readings. Okay, now see here, you will get the characteristics of input voltage versus input current. When VEC is equals to 0, VEC is equals to 2 volts, you will get a characteristics like this. Okay, if you increase the output voltage, the characteristics will shift from left side to right side. Okay, these are the input characteristics in case of common collector configuration. Next we will discuss about output characteristics of common collector configuration. In common collector configuration, now see here, the output characteristics are plotted between output voltage, that is VEC versus IE. Okay, VEC output voltage versus IE by maintaining input current as constant. Okay, that means initially set IB is equals to 0. Okay, vary the emitter collector voltage in steps and note down the corresponding emitter current readings. Okay, after that, by maintaining this VEC as constant, right, by maintaining this VEC as constant, increase the base current to 20 microamperes. Okay, and repeat the same procedure again, increase the emitter collector voltage and note down the corresponding emitter current reading. You will get the graph like this. Okay, in this way you will get the output characteristics in case of common collector configuration. Okay, now we observe all those waveforms, right? That means all those characteristics, that is common base, common collector and common emitter configuration, right? If we compare those three characteristics, these are the comparison of common base configuration and common emitter configuration and common collector configuration. From the VI characteristics, this common base configuration is having low input resistance, whereas common emitter configuration is having moderate input resistance, whereas this CC configuration is having high input resistance. Okay, whereas common base configuration is having high output resistance, always which are opposite. When input resistance is low, here output resistance is high. Moderate and output resistance is also moderate. Yes, here also moderate but slightly less, but here also the output resistance is moderate. Okay, next, here current gain is unity, here current gain is high, here current gain is high in case of common collector configuration. Similarly, voltage gain is about 150, voltage gain is about 500, voltage gain is less than unity. Okay, next, common base and common collector configuration offers 0 degrees phase shift between input to output, whereas common emitter configuration offers 180 degrees phase shift from input to output. Okay, common base configurations are used in high frequency circuits. Okay, common emitter configuration used in audio frequency circuits like amplifiers. Okay, whereas common collector circuit used as impedance matching circuit. Okay, these are the comparison of common base and common emitter and common collector configuration. Okay, thank you.